Hi, my name is Aiman Farhan Hishanuddin, Master student from the Faculty of Electrical Engineering, University Technology Mara. Today, I am honored to be presenting our paper, The Rise of Quantum Intelligence in Multiple Sclerosis Diagnosis, a Scopus-based bibliometric roadmap. Without further ado, let me explain the background of the study. So what is multiple sclerosis? Multiple sclerosis, or MS, is a chronic and inflammatory neurological disease that affects the central nervous system of a person. Currently, the best way to diagnose and monitor MS is through magnetic resonance imaging, or better known as MRIs. However, manual analysis of MRI scans is not only time-consuming, can often be laborious due to additional variables that may be found in an MS-affected patient. Fortunately, artificial intelligence, particularly deep learning, has revolutionized medical image analysis by mitigating those issues. Also, in recent years, a new class of algorithm called the quantum-inspired neural networks, or QNNs for short, has started to emerge. These networks leverages the principles of quantum mechanics, such as superposition and entanglement, all within a classical computational framework which helps solve complex pattern recognition problems more effectively. Therefore, the applications of these QNNs to MRI analysis may hold a potential to improve MS diagnostic accuracy. In fact, recent studies have begun to show the transformative impacts of QNNs. One study demonstrated the superiority of quantum-inspired model in segmenting white matter lesions with higher fidelity as compared to state-of-the-art deep learning methods. But despite promising progress, the field is still in its nascent stages. The goal of this study is to create a bibliometric analysis to map the current research landscape and future trajectory of quantum neural networks in MRI-based MS diagnosis. To achieve this goal, the study aims to analyze the publication trends, the key research themes, and influential works related to QNNs and MRI-based MS diagnosis. By achieving these goals, we can provide valuable insights for researchers to navigate and contribute to this rapidly advancing field. So let us move to the methodology of this study, where we will discuss how and what tools we use in this study. In this study, we've decided to use Scopus as our main database to search for publications related to the study between the year 2006 and 2024. By using terms such as multiple sclerosis, quantum, and machine learning in the search query, we were able to extract a final dataset of 560 peer-reviewed documents published within the last 20 years. For the analysis, ScientoPy was used as our main analysis tool. ScientoPy is an open-source Python-based tool that is specifically designed for scientometric and bibliometric analysis. It is particularly useful for this study as it is fully compatible for Scopus datasets. And in this study, we will be using it to analyze the publication trends, the keywords, and author statistics in the dataset. Now that we're done analyzing our dataset, so let's discuss our findings. For publication trends, this figure shows the annual publication trends on QNNs or machine learning in MS detection. As we can see, there has been significant growth over the past 2 decades, with a pronounced acceleration in recent years. The data here is categorized by document type. Articles represent the most and rapidly growing category, where sometime in between the year 2013 and 2016, there has been an exponential growth in publications. This is also true for conference papers and reviews, where in recent years there is an increasing volume of publications which emphasizes the dynamic and experimental nature of the research. This chart shows the trend of publication distribution across various journals and conference proceedings for QNNs or machine learning in multiple sclerosis detection. As we can see in this chart, multiple sclerosis and related disorders emerged as the leading journal with approximately 18 publications. This indicates a strong focus on clinical applications and relevance to this specific disease. Following that, lecture notes in computer science is the second most frequent source, with around 14 publications. This underscores the foundational role of computational methods in this research. Other significant journals include Neuroimage Clinical, around 12 publications, Computers in Biology and Medicine, 11 publications, and Scientific Reports with 10 publications. The diversity of these top sources demonstrates the field's interdisciplinary nature between neurology, computer science, and biomedical engineering. For the next analysis, this chart shows the geographic distribution of publications from the 10 most active countries in the field of quantum neural networks or machine learning for multiple sclerosis detection. This chart presents both the total research output and the percentage of work published in the recent 2023 to 2024 period. From this analysis, we can see that the United States leads with over 150 publications, with strong output in recent years. India, however, is the fastest rising star, where 72% of its contribution came just from the past 2 years. Other active contributors include China, Iran, and major European countries like Italy and the United Kingdom. This is the data we obtain from analyzing key research areas. This chart provides an analysis of keyword trends in research related to quantum neural networks or machine learning for MS detection. The chart highlights the evolution of research focus by comparing publications before 2023 and those published the year after. As we can see from the chart, multiple sclerosis and machine learning are the most frequent words. However, since 2023, newer terms like biomarkers, deep learning, and artificial intelligence have surged. Notably, biomarkers appears in 75% of recent papers, suggesting a shift towards precision medicine. Meanwhile, older methods like support vector machines are declining. And for citation analysis, this table presents the most influential papers in the field of machine learning for multiple sclerosis detection. Each of these papers have garnered at least 50 citations as of July 2025. This analysis, based on the Scopus dataset, highlights the foundational and breakthrough research that has shaped this domain. From this table, we can see that the most cited work is from the 2020 review, Applications of Machine Learning to Diagnosis and Treatment of Neurodegenerative Disease, with 421 citations. Its high impact underscores the broad significance of machine learning in neurology. And following close behind is the 2016 article, Deep 3D Convolutional encoder networks with shortcuts for multi-scale feature integration applied to multiple sclerosis lesion segmentation, which has occurred 404 citations. This paper's influence highlights the pivotal role of deep learning techniques in the crucial task of segmenting MS lesions from MRI scans. Other highly cited works further emphasizes the focus on improving automated lesion segmentations. The inclusion of several recent reviews also indicates this field is rapidly advancing. So, in conclusion, this bibliometric analysis provides a comprehensive overview of the research landscape for QNNs in MRI-based MS diagnosis from the year 2006 to 2024. And to summarize our findings, the research in MS diagnosis using AI is growing rapidly. The field is global, involving multiple countries, and it is also interdisciplinary. There is a clear move towards deeper automation, precision diagnosis, and quantum-inspired intelligence. So hopefully this bibliometric roadmap will provide a valuable reference for anyone willing to contribute meaningfully to this emerging field. And before I reach the end of this presentation, I would like to acknowledge that this work was supported by the Malaysian Ministry of Higher Education under the FRGS grant and by University Technology Mara. We would like to thank all collaborators and contributors who made this study possible. And so this concludes my presentation. Thank you for your attention.